Radhe Radhe. So in this video, I'm going to discuss the K-odd sum problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. The problem statement is very simple. You're given two numbers, n and k. You have to find a permutation of size n such that there are k positions where the ARR of I plus ARR of I minus I plus 1 or I minus 1, whatever you may think it to be, like, doesn't matter, is odd. Okay, very clear. So how we are going to do this? Actually, remember one thing, k ranges from 1 to n minus 1, and this is proof that it is always possible to make it. So the basic approach, this is the output that has been given in the sample test cases, but this is a modified output that we are going to use, and I will tell you why we are going to use this. So what we can do is, we can arrange the numbers as even dot dot dot, then odd dot dot dot, or odd dot dot dot, and even dot dot dot. Now after you have done with this, so you can do what, if you like look at it minutely, there will be only one pair which will give you odd sum. Okay, so for this the k is equal to 1, and even for this k is equal to 1, because only one pair will be there, right? And in order to increase the value of k, what you can do is, you can, like, if there is one pair, you can, now let's say you want to make it 2, right? So you can take out a even from here, and at the end you can add a even over here, so it becomes 2. Okay, similarly for this also, if you want to make it 2, you can cut out a odd from here and add an odd over here, which makes it one more pair, and that is 2, right? Now what if we want 3? Okay, if we want 3, then it is a different thing. Okay, so you don't need to cut this off, this remains over here. You just need to cut this off and put it over here, so that 1 2 3. Okay, clear? So what we can do is, we have to find out how many we have to append at the end and how many we have to append at the middle. Okay, how we are going to find it out, I'll go to this later. But tell me one thing, what do you think, which is a better approach, this even odd or odd even? Obviously this odd or odd even is a better approach, because let's say the n is an odd number, so from 1 to n, the number of odd numbers is going to be greater than the number of even numbers. Okay, clear? So this is the reason, because since we are like playing with the position of the odds, so it is better to keep more odd numbers in our hand. So this is a better approach, this odd even. So how many are going to be appended to the end and how many are going to be appended to the middle is the main question that we are going to, that arises. Okay, now let's say for 1 we see, so let me make a table of end, middle, and value of k. Okay, so if the value of k is 1, so it is basically nothing appends at the 0, because it is already in this odd or odd even thing, right? So if the value of it is 2, okay, if it is 2, then what we have to do is, we have to append 1 at the end, right? You have to append 1 at the end, and the middle nothing. So if it is 3, then in the middle there is 1, but over in the end there is nothing. If it is 4, then in the end is 1 and middle is 1, because if, like, let's say odd even, so in the middle there is 1 and in the end it is 1, because 1 2 3 4. Okay, now if we want to make 5, so we don't need this, we just make it over here. Okay, 1 2 3 4, and append a even over here, 5. Okay, clear? You're getting it? So this is how we are going to do it. So for 5, the end is 0 and the middle becomes 2. So now if you notice one thing, it is in the pattern, the middle is in the pattern 0 0 1 1 2 2, which makes us remind of the thing that is, for 2 and 1 it is going to be 0, for 4 and 3 it is going to be 1. So now you can make a pattern out of this, and end is going to be 1 only when it is an even number, because it is in the form 0 1 0 1 0 1. Okay, so I hope this is clear. Like, this is basically, okay, I'll write it down. This is basically k minus 1 by 2. Okay, because if it is 1, 0 by 2 is 0. If it is 2, 1 by 2 is 0. For 3, 3 minus 1, 2 by 2 is 1. Okay, since there is like 2 is the range, so it is going to be 2, and since 1 is at a lagging thing, so 3. So this is k minus 1 by 2 is the middle formula for middle, and the formula for end is k plus 1 mod 2, or k minus 1 mod 2, works both way. Okay, so k minus 1 by 2 is middle and k minus 1 mod 2 is end. Clear? So once you're done with this, what we have to do now is now we have to just simply like do the operations. Okay, so I won't get into the details of the operations that you have to perform. You can simply make an array where in the beginning you're going to make all odd numbers, then even numbers, and accordingly the number of middle you're going to append the odd numbers from here and append it over here, another odd number over here, over here. Okay, like this. So that is a very simple operation. You can do it. I won't get into that details, but this is how you have to do it, and this is the mathematical proof that basically this is the mathematical proof that for all k belonging in this range 1 to n minus 1, it is possible, and using this mathematical proof you can find the answer. So for this, see, initially, so k is equal to 1, so we make no changes, so that is 1 2, the permutation remains the same, so 1 2. For k is equal to 2, so it is 1 2 3 4, and if we write it as the odd numbers at the beginning and the even numbers after that, so we get 1 3 2 4. Okay, so after we get 1 3 2 4, what we are going to do is it is 2, right? So if it is 2, basically end there is 1. So what we do is we cut this, sorry, so this is 1 2 3 1 3 2 4. Okay, so we basically take out one odd from here and put it at the end, so it becomes 1 2 4 3. So see, it is 1 2 4 3. You can even put that 1 out of here. You can even do this 3 2 4 1. Even this works, but it's up to you. Okay, it's up to you. 3 2 4 1 is also a valid thing. 3 2 4 1, like if you're removing it from the beginning, then 3 2 4 1. If you're removing it from the end, then 1 2 4 3. Okay, so this is how it works. Now you can check this out. Okay, 3 2 4 1. So you can check that 3 plus 2 is 5, 2 plus 4 is 6, 4 plus 1 is 5. So 2 are odd, right? So 2 are odd. So that's how it works. Okay, that's it from my side. Thank you.